So 6.6 is a continuation of simplifying radicals or rational exponents. We need to know the same thing as we did before. We need to know how to change any radical to a rational exponent, all right? Or backwards, a rational exponent to a radical. What's a rational exponent? It's an exponent that's actually a fraction, okay? And if you do have any item to a rational exponent, a fraction that is in an exponent position, the numerator is the power and the denominator is the root. All right, so we should be able to go from radical to exponential form or from exponential form back to radical form. So on these first examples, they want us to, number one, rewrite your x to the 2/3 in radical form. So what kind of radical am I going to have? What kind of root? Cube root. So everybody please write down cube root right there of the x to the second power on the inside. That is your answer. Another way of writing the answer, even though I don't normally do this, but you could write it cube root of x and make the whole thing be to the second power. My point is the power of 2 doesn't have to be inside of the radical. It could be outside of the radical in parentheses. Either way is totally fine. I will usually write my answer like this, okay? Number 2, write that radical into exponential form. So we know we have the base x, but what's my rational exponent going to be? 4/5 power over root. The power is 4, the root is 5, so x to the 4/5 power, okay? Now, number 3, it says evaluate x to the negative 2/3. Now, we do need to remember every single rule that exists with exponents. Do we remember what happens when you have a negative exponent like on number 3? What do you do when you have a negative exponent? Anybody? Like if I had, let me do this on the side right here. If I had x to the negative 2 power, what would I do with that? Nobody remembers? Algebra 1 stuff. You grab it and you move it to the other side, right? So your answer would be 1 over x squared. You guys remember that, right? No? Really? Some of us? Any negative exponent, you move it to the other side and the exponent becomes positive, okay? So even if I had like 2 over 3 to the negative 2 power, I could take that negative exponent, move it up, and it'll become 2 times 3 to the positive 2, which would be 2 times 9, which is really 18. Anyways, negative exponents, you always move it to the other side and they become positive. If we do not remember these rules, these basic rules from Algebra 1, we're not going to be able to understand this section. So please remember that. Negative exponents, you move them to the other side, they become positive. Let's go with something even more basic. What if I had x to the second times x to the third? That's exponent rule. What do we do there? You add the exponents. Likewise, x to the second to the third, what do I do with the exponents right there? Multiply. So we need to have these fundamental rules of exponents engraved in our minds so we could actually succeed in this section. So you see right here on number 3, we have a negative exponent, and what do we do with negative exponents? Move them to the other side and they become positive, right? So right here, we're going to grab this guy and move it down to the other side. So you're really going to have a fraction, nothing left up on top, and on the bottom you're going to have 8 to the 2/3 power. Now, up here on our notes, it says don't leave a radical or a rational exponent in the denominator, because a rational exponent is a radical, but you don't want to leave those guys in the denominator. So right here, I have 8 to the 2/3 in the denominator. I don't want that rational exponent. Technically, that's the third root of 8 squared. So if I wanted to, I could multiply both top and bottom by what? 8 to the what? Using rule 1 of exponents. You see, this is a 2/3. When you multiply with the same base, what do you do? When you multiply with the same base, what do you do with the exponents? Add them. So 2/3 plus how much more will make it 1 whole? 1/3, right? So I could multiply both top and bottom by 8 to the 1/3. And then I'd get 8 to the 1/3 up here over 8 to the 2/3 plus 1/3 is 3/3, and 3/3 is really 1, which means 8 to the 1, which means you don't even need anything. It's just 8. Make sense? And then we could go further. We could take that 8 to the 1/3 up on top and recognize that that's the third root of 8 over 8. And the third root of 8 you could actually do, what's the third root of 8? What times itself 3 times gives you 8? 2. So on top you get 2, on the bottom you have 8, and 2 eighths reduces down to what? 1/4. There's your final answer. Confusing? Heck yeah. Is there other ways of doing it? Heck yeah, there's so many different roads to the same place, right? So this section, this middle section of chapter 6, the problem that you guys are going to encounter is the freedom. You have too many choices. That's what it is. It's not like Algebra 1 where like, oh, I need to get rid of this +2. I need to do a -2, right? You got so many different ways of looking at these problems, very fluid. So for example, let's go back to this right here. Let's go back to that right there, all right? And instead of multiplying by 8 to the 1/3 to make it whole, instead of doing that, let's just take a look at this 8 and let's change it to be some type of number to some type of exponent. So 8 could really be what? Could it be 2 squared? Could it be 3 squared? Could it be something to the third power? 8 could really be rewritten as what? 2 to the, hello? Anybody awake? 8 could be rewritten as what? 2 to the third, thank you. So check this out. I'm going to take that fraction right there, the 1 over 8 to the 2/3 power, and instead of 8, I'm going to put parentheses down here, and I'm going to write it as 2 to the third, because 2 to the third is the same thing as 8. And then I'd have the outside power 2/3. Why would I do that? Just for fun, to see if I could mess with this, right? Change it and then see if I could do anything else with it. So right here, I have a power to a power. So what do you do when you have the power to a power? Multiply. So what's 3 times 2/3? Come on, guys, I'm recording. 3 times 2/3? 2, thank you. The 3 cancels with the 3, you end up with 2. So what do you really have? You have 1 over 2 to the 2, which is really 1 over 4, which is really the same answer. So there's like so many different ways you could do all these problems, right? Again, I think the problem that most students have with this section is the freedom that you have to go all these different paths. You might be doing your problem completely different than your partner. You get the same answer, both correct, right? Number 4, let's evaluate. By the way, number 5, if you have the old worksheet, this should not be a plus, it should be multiplication, all right? Let's go to number 4. What could I do here? There's so many different ways I could do this problem. Okay, anybody have any idea how we could do this? How we could simplify this, evaluate this? So there's so many different ways of doing it. I'm going to go, I'll explain it a couple different ways. First of all, this fraction right here, this power, this rational exponent is an improper fraction. You could make this a mixed number. So you could take that base -16 and have that 3/2 become what as a mixed number? What's 3 divided by 2? 1 and 1/2. So you could use rule 1 of exponents backwards, where you split the base -16 times -16, and the first -16 will have the power of 1, and the next -16 will have the power of 1/2. Does that make sense? This is one way of dealing with this, just changing that improper fraction to a mixed fraction and then splitting the base using rule 1 of exponents backwards. So what is -16 to the 1? That is simply -16. And what's this is really a square root, right? That's really a square root of -16, which is really what? 4i. So we really have -16 times 4i. -16 times 4i is -64i. That's the answer right there. Is there another way of doing it? Heck yeah. You could actually take this 3/2 and focus on the root and keeping it as a power. So if you wanted to, you could say, take the -16 And let's do the square root of it, but then you have the power of 3 on it, right? Even though I wrote it as the power of 1/2, we know that that's really the square root. So what is the square root of negative 16? 4i. So you'd really have 4i to the third power. So what is 4i times 4i times 4i? That'd be 4 times 4 times 4. That is 64 I to the third. What is I to the third really? It's really negative I. So you'd have, you guys remember that? So that'd be negative I that you're multiplying by. So your final answer would still be negative 64I. Same exact answers down here. So once again, the problem that most students have is the freedom, the many different choices that you could have on simplifying these. Okay. So number 5, what are we doing here? We're multiplying two terms with the same base. What do you do with those exponents? Add them. So what's your final answer? G. Why? Because 2/3 plus 1/3 is 3/3. 3/3 is really 1, and g to the 1 is really just g. How about number 6? What do I do when I have a power to a power? Multiply. So I really have the fraction 1/2 times the fraction 4/5. I could cancel the 4 with the 2, have a 2 up there. And my final answer will be u to the 2/5 power. Now, if the instructions say write it as a rational exponent, then this would be your answer. But what if I said write it as a radical, in radical form? What would that answer be? The 5th root of u squared. The 5th root of u squared. Or you could put it the 5th root of u in parentheses with the power of 2 on the outside. Either way is correct, but it depends on the instructions. Do I want it in exponential form, or do I want it in radical form? Number 7. Anytime you have a negative exponent, what do? Move it to the other side. All right, so we're going to take this guy, move it down. I'm going to have nothing left up on top, so I have a 1 up there. The y to the negative 3/4 becomes y to the positive 3/4 on the bottom. Okay, now you do not want to leave a radical or a rational exponent because they're both the same thing. You don't want to leave that in the denominator. So let's get rid of this fraction, the power of 3/4 right there. So I'd have to multiply by y to what power in order for it to become one whole? 1/4. And what I do to the bottom, I do to the top. Y to the 1/4. So my answer up on top is y to the 1/4 power. On the bottom, I have y to the 3/4 times y to the 1/4. That's y to the 4/4, which becomes y to the 1, which is just y. So if they wanted the answer in exponential form, that would be your correct answer. If they want your answer in radical form, then in the numerator you would have the 4th root of y all over y. So it depends if they want exponential form or if they want radical form. And I will be asking you specifically to write the answer in exponential form or write it in radical form. What's that? Looks like there's a hair on it when I took a picture. Oh well. Number 8. Same deal. How about you guys try it? B to the 3/5 over b is absolutely right. Once again, let me quickly explain. This whole thing goes down to the bottom. You have a 1 up on top. You have b to the 2/5 on the bottom. You want to get rid of this exponential, this rational exponent. So you'd have to multiply by b to what power to make this one whole? 3/5, because 2/5 plus 3/5 would give you 5/5, which changes just to b, right? B to the 5/5 is just b to the 1, which is just b. Now when you multiply it on the bottom, you also have to multiply it on the top. So up on top you get b to the 3/5. So your final answer in exponential form is b to the 3/5 over b. Now if for some reason I'd ask you to write the answer in radical form, it would be the 5th root of b to the 3rd power, the 5th root of b to the 3rd power. Either answer is 100% correct, but pay attention to the instructions. Number 9. What could I do here? I do want to show different methods, all right? So one method would be to simply move this whole thing up. And when you move something up, what happens to the exponent? Whenever you move a term from one side to the other, what happens to the exponent? Changes sign, changes sign. So you're going to be multiplying by x to the negative 4/7. So see, by me moving it up, you're going to be able to now add the exponents because you have the same base. You're multiplying two terms with the same base. So you're going to be able to combine 5/7 with negative 4/7. What is 5/7 plus negative 4/7? 1/7. So there's your actual final answer. I think that's the easiest way to go, where you have x to the 1/7 power. Now, if for some reason they asked you to write it as a radical, that would simply be the 7th root of x. So, of course, I could have explained it a different way. Do you guys want me to show you a different way? No? Okay. So it's not about learning one way of doing it. It's about understanding all these different possibilities and being able to apply them, right? Number 10, what could we do? I know a lot of us are like, oh, forget that. It looks too complicated. I don't even want to think about it. Well, let's think about it. What could we do? Could we? We could move this up to the top and make it positive, right? Or if we wanted to, we could actually multiply these guys together and add those exponents, right? And then move it. Or we could actually move this one down and have all of them on the bottom. So there's so many different ways of doing it, right? What should we do? Pick one.
The first one.
I don't even know what the first one was.
Move the negative 3/4 on the top.
Okay. So we're going to take that negative 3/4, move it up to the top. So x to the negative 3/4 is going to go up. It's going to become x to the positive 3/4. And you know what? Let me try something completely different than my other classes. Let me take this, actually, let me take the x to the 1/2, not the 3. The 3 doesn't have the 1/2 power. But I'm going to take that x to the 1/2 and move it up also and make it x to the negative 1/2. That way, I have x to the negative 1/2 times x to the 2/3 times x to the 3/4. And I'll have a 3 on the bottom. Let's not forget about the answer. It's going to have a 3 on the bottom. But right now, I could now focus in on all of the exponents, because when I'm multiplying all these terms with the same base, I really add those exponents. So I really have a addition-subtraction problem with fractions. I have a negative 1/2 plus 2/3 plus 3/4. So I need a common denominator. What would that common denominator be? If we just focus in on these fractions that we're adding and subtracting. Common denominator? 12. Okay, so let's change them all to 12. 12, 12, 12, plus. How do we change the 2 to become 12? We multiply by 6. So multiply by 6, you end up with the negative 6/12, which is the same thing as negative 1/2. Multiply by 4, you end up with 8/12, which is the same thing as 2/3. Multiply by 3, you end up with 9/12, which is the same thing as 3/4. So now we're able to combine all the numerators. Negative 6 plus 8 is 2. 2 plus 9 is 11. So we end up with 11/12. Now, what the heck is this 11/12? That was the exponent on the x on the numerator. So on the numerator, we have x to the 11/12. And that's it. That's your final answer. Of course, it could have been done many different ways, but that is your final answer. If they do ask you to write it in radical form instead of exponential form, you would have the 12th root of x to the 11th all divided by 3. So it depends what the instructions say. So I'm pretty much done with the practice problems. Now I need you guys to practice by looking at our worksheet. We're doing 6.6 WSP. We're doing 1 through 17 odd. 1 through 17 odd. So from here all the way down to here, we're only doing the odd ones. And then from 18 to 29, we're doing all of them. Okay? So again, let me reiterate that there's so many different ways that you could actually do these problems. Let's take this simple question number 9, 81 to the 1/4 power. what does 1/4 actually mean? The power of 1/4. What does it actually mean? The fourth root, right? So you're thinking the fourth root of 81. That's really saying what number times itself 4 times will give you 81. So if you go 2 times 2 times 2 times 2, will that give you 81? No. If you go 3 times 3, that's 9 times 3 is 27 times 3. That is 81. So the answer is 3. Of course, the calculator will do this for you, but the whole goal of this, what I want from you guys is for you to become flexible, get your minds flexible, right? So this 81, what could you think of in terms, like 81 could really be rewritten as what? 9 what? 9 to the
4.
9 to the 4th is 81?
Squared.
9 squared is 81, right? Okay, so what if I did this? What if I just changed 81 just for fun as 9 squared? I know 81 is a perfect square number, so I could just rewrite it as 9 squared, and it's to the power of 1/4. So why would I do that? Well, because now, at the very least, power to a power, I could multiply. And what's 2 times 1/4? 2/4, which is really 1/2. And 1/2 is really the square root. And the square root of 9 is really 3. Same exact answer. You like the top one better? That's fine, right? Okay. But what I'm saying is there's so many different ways of doing this problem. So many different ways. As a matter of fact, you could have actually taken, like right here, you could have taken that 9 squared to the 1/4 power, and you could have rewritten it, instead of 9 squared, you could have said 3 squared to the 1/4. So you'd have power to a power to a power, multiply 2 times 2 is 4, 4 times 1/4, that's 4/4. And 3 to the 4/4 is just 3, same answer. Okay, so I really want you to be flexible. I want you to be able to think differently. You could be solving the problem completely different than somebody else and get the same answer. Is there any, just by looking at this paper, that you guys are just like, wait, I'm not going to be able to do that one. That one looks too confusing. 17? Okay, so if we look at 17, what could we do here? Well, could we do that? Do we understand what that means?
5.
That's really just 5. So, all right, there you go, just 5. That's nice and easy. Instead of 25 to the 1/2, it's really just 5. Now, what about that negative 64 to the negative 1/3? Well, first of all, anything with a negative exponent, what should you do? Move it to the other side. Okay, so let's do that. Let's take this whole thing and move it underneath the 5. So at the bottom, I'm going to have negative 64 to the positive 1/3. And what's negative 64 to the positive 1/3? 4, right? The power of 1/3 really means a third root. So what we really have here is 5 over negative 4. Final answer is negative 5/4. Is that the answer on the back? All right, guys, so let's work on this. Answers are in the back. Ask me for help if you need it.